Okay, hello, this is Michael Scott, and this is the systems diagram for the Capstone Class final project. This project was to use a conveyor belt and an industrial robot to move and sort objects, in this case Jenga blocks, down a conveyor belt using barcodes, and then sort them into one of three categories depending on the type of code. As you can see, we have a number of different components in this. We have a light tower, barcode reader, diffuse sensor, which is actually a fiber optic proximity sensor, and the robot arm, industrial, pneumatically powered with a vacuum chuck for picking up the blocks. To control the system, I used an Allen Bradley MicroLogic Series 850 programmable logic controller and a HMI, which is a human-machine interface. The goal of the system was to move a part down the conveyor belt where the part, which has a barcode taped on it, will be scanned by the barcode reader, and then at the end of the belt will trigger the sensor to stop the belt and tell the robot to pick it up and put it into one of three bins depending on the code scanned and sent to the PLC. In the next two sections, I'm going to show you how I programmed it, what the coding and stuff I used was, and then show you how it works. So, thank you for watching. Hello, my name is Michael Scott, and this is the ladder logic I use to control the conveyor belt that leads up to the robot. I'm going to move along fairly quickly through this, so feel free to pause the video and read the notes up here if you want. First off, I should mention you'll see these tags here and here throughout the programming, which they relate to the HMI, which I'll cover in the next segment. First off, the start button, when pressed on the tag on the HMI, it'll latch this startup bit, which will control the rest of the processes, the running process. First off, when the start button's pressed, rungs 2 through 5 here will control the starting up process. The conveyor belt has a light tower on it, and we were required to have it flash yellow 5 times before actually starting as a warning sequence. So, and these control that sequence. Also, the yellow light can also be turned on by the proc sensor when that's triggered, which I will get to in a minute. So after that startup bit, the conveyor belt will start, and light will turn green, yellow light turns off, and then the blocks are sent down the conveyor belt. For the rest, for a good chunk of this program, it's going to be about the barcode reader, which is set up in the middle of it to read the barcodes stamped on the blocks. Here we have the count tag, which again relates to HMI and counts the total amount of the blocks passed through. So every time it's triggered, it increases by 1. Here we have what actually reads the codes on the blocks. So it translates to a coding tag, which is then sent on throughout the rest of the program. These 3 lines here, not only do they count what type of tag, but they also, again, they're used down here. But here, if the coding reads all 1s, and then the type 1 tag will increase, these 3 basically keep track of each individual amount and type of the blocks. Lines 12 through 14 are here's where we get into turning it over to the robot. Depending on whatever type of code is read, it'll latch a bit, but it'll also unlatch the other 2 bits. So if it reads all 1s, then it'll also unlatch types 2 and 3 here. So make sure there's no mixed signals sent through it. So when the block reaches the end, program proximity sensor detects it. The proximity sensor will flash. The yellow light will turn on, and depending on whatever block type is used, or block is read by the barcode reader, it'll activate a small bit. Actually, I should say it'll activate an output, which will send the signal to the robot, which will send an output signal on to tell the robot to follow a particular path and sort it into one of 3 separate bins. Here, now we're going to talk about the stop sequence. The stop button tag will unlatch the startup bit, which will stop the entire program and the conveyor belt, and it'll also start up the stop sequence. When that's turned on, the red light will flash for about 2 seconds, and then when that part is done, the stop bit will unlatch, therefore resetting the entire thing. Also, if you probably noticed throughout the program here, the stop button tag will also reset each counting tag, so that way you can start over again. As well as stopping the sequence, the stop bit can also be pressed during the startup sequence, so while it's flashing yellow, so just in case you get caught or something like that, you can stop it before the conveyor belt even begins. Hello, this is Michael Scott, and here I'm going to be talking about the HMI screen that controls the robot and the conveyor belt. On this screen are the various types of tags that were seen in the previous segment, talking about the ladder logic. The start and stop here are both buttons that can be pressed. The start button will start the sequence, and the stop button will stop it, of course. I made them large enough here so that you can press it so you don't press anything else accidentally, or in case of an accident they need to be stopped immediately. Over here we have the type detected, which basically whenever the barcode reader scans a code, the code in numeric form pops up here. Also, whenever it scans a code, each individual type is read, and depending on what type it is will be counted. So if it's a type 1, then the increment of type 1 increases by 1, 2, and 3 respectively, depending on type. Here we have the total, which when counted increments by 1 regardless of type, so it keeps track of the full amount. Hello again, this is Michael Scott, and here we have a few pictures I'm going to show you, if you can see them. First, this is the overview of the setup. We have the robot arm, we have the conveyor belt with accessories, over here the controllers, the HMI and the PLC and all the wiring, and the bins into which the Jenga blocks will be sorted. So here we have the conveyor belt itself with a proximity sensor and the barcode reader and the light tower. As you can see, the barcode reader is currently reading the barcode on the Jenga block, and the light is green, which means the conveyor belt is currently moving. I put up some support structures so that way it'll straighten out the Jenga block for the barcode to accurately read it. And here you can see the Jenga block is at the end of the belt, and the proximity sensors picked it up, and the light is yellow, and the belt has stopped, so which will allow for the arm to come down and pick it up. Here we have the controllers, the HMI and the screen, which is currently being glared out. Here we have the PLC and the 24 volt power supply and a 5 volt converter. And in the output side we have 3 outputs, which actually go directly to the controller for the arm, which I will show you in a second. But all the other stuff is wired directly into the PLC. And here we go. Here we have the controller and the program uploader for the robot arm. Basically, you plug in your USB drive into the controller here and upload the program of your choice, and whatever program you have in here was what the robot will follow. So it makes it a lot easier to test and actually move around. And here we have the robot arm itself. It's a ABB industrial 6-axis pneumatic powered arm with a vacuum chuck on the end in order to grip the pieces and sort them into the 3 bins. Hello, this is Michael Scott, and this is going to be the video I'm going to show you of the robot actually working in accordance, in conjunction with the conveyor belt. Here it's picked up a Jenga block and is now putting it in the bin. That was a type 1, as you can see. Now it's going back and resetting a position, and I'm in the way. Right now it's moving, and here, as you can see, it's moving fast enough so that the barcode reader only scans it once, and now the proximity sensor detected, the light tower is yellow, and the robot arm is picking it up. And that was a type 2. And that's it.